Hello everyone, welcome to Analysis and Design of Algorithms. In the previous video lecture, we have discussed about the order of growth and the several time functions which are used to indicate the order of growth for various algorithms. In today's lecture, we'll be discussing about frequency count method. So what is this frequency count method? It is a method which is used to calculate the time complexity of an algorithm by assigning a certain unit of time to each statement of the algorithm, right? So this frequency counting method is going to help us in identifying the order of growth or the time complexity of any algorithm. Let's discuss this frequency count method with the help of an example. I have an algorithm here. This algorithm finds the sum of array elements. So this is an algorithm. So this is a for loop, and this statement is calculating the sum of all the array elements and it is returning the sum. So let's find out how to use frequency count method. So as the definition says, we have to assign a certain unit of time to each of the statement of the algorithm. And again, let me remind you that this method is going to only give us an approximate or an estimate of the time complexity of any algorithm, right? So this is the first statement where S is assigned 0. Let's assume that this takes 1 unit of time. We'll assign a value 1 to it. Next we have a for loop. This is initialization, this is checking of condition, and this is increment, post increment. How many times will this for statement execute? This statement, I'm not talking about the loop, I'm talking about this statement. How much time will it require for this statement to execute? This statement will execute based on this condition over here, I less than n. It is going to execute for n plus 1 times. Now how is it n plus 1 times? Assume that the value of n is 0. Initially I value is 0, 0 less than 5, condition is true. I value becomes 1, 1 less than 5, condition is true. 2 less than 5, condition is true. 3 less than 5, condition true. 4 less than 5, condition is true. After this, I plus plus, I becomes 5, I less than 5, condition is false. So the loop will stop over here, or the condition checking stops over here. So let's find out, let's count how many times this condition is executed. 1, 2, 3, 4, 5 and 6. So 6 is 5 plus 1. Therefore it is n plus 1 times. We are not interested in this initialization and in this post increment that is happening inside this for loop. We are only interested in this condition because the loop will execute only based on this condition, right? So this statement over here will take n plus 1 time units for execution. Coming inside this loop, S is equal to S plus A of I. This statement is calculating the sum of all the array elements. How much time will it take? So this for loop or the statements within the for loop will execute for n times, not for n plus 1. Alright, when the condition is false over here, 5 less than 5, the control will not come inside this. That is why it is only 1, 2, 3, 4 and 5. 5 is equal to 5, that is n. That is why this statement inside the loop takes n unit of time to execute. Let's come out of this. This statement is going to take 1 unit of time to execute. Okay, so let's add up this. Let's find out the total time. The total time we have to find out how it is. So it is 2n plus 3, right? So you can say f of n is equal to 2n plus 3. So we have a polynomial over here, 2n plus 3. What is the highest degree of this polynomial? N. So the time complexity is order of n. Time complexity is order of n. So this algorithm takes a time complexity of n. So which means the order of growth of this algorithm is linear. Alright, so the next algorithm whose time complexity that we're going to find is an algorithm to find the sum of two matrices. So this is an algorithm which is written. I have a function, I've passed two arrays and the value of n for this is I loop, this is j loop, and this is the statement which gets or which calculates the sum of array elements. Let's see step by step and let's assign a certain unit of time to each of these statements. As we know, this statement is going to take n plus 1, a time of n plus 1. Right? The statements within this loop, this is the j loop, this is the second loop which falls inside the I loop. So the statements within any loop or the statements present inside any loop, as we have seen in the previous lecture or in the previous example, it is n. But this is again a for loop. Now what about the time taken by this j less than n? It is n plus 1. So it is n into n plus 1. Let me repeat once again. This outer for loop, as we have seen in the previous example, this particular condition or this time taken by this condition or this statement to execute is n plus 1. Every statement within a for loop takes how much time? N unit of time to execute. But this statement is again a for loop which is going to take n plus 1 units of time to execute. Hence it is n into n plus 1. Next, this statement which is inside this for loop and also it is inside this I loop. It is also inside j and also inside I. So the statement which is inside this loop, it is going to take n unit of time, and it is also a part of this I loop. That is why it is going to take another n units of time. That is why it is n square. Let's add up this. So this is n square plus n. Alright. So this is 2n square. How much does it come to? 2n square plus 2n plus 1. So n square into n square and n square is 2n square plus 2n plus 1. So we have f of n is equal to 2n square plus 2n plus 1. This is a polynomial whose highest order of degree or whose highest degree is n square. That is why this algorithm's time complexity is n square, which means that it is quadratic. N square refers to quadratic. In the next example, I have another algorithm over here where p value is initialized to 0. I have a for loop, and inside this the value of I after every increment is added to p, and there is a condition which is checked, p less than or equal to n. So let's find out the time complexity of this particular algorithm. Let's trace it. I have I and I have p. So initially I value is 1. So when it comes p is less than or equal to n, condition is true, so it will come inside the loop. 0 plus 1 is equal to 1. I value becomes 2. 1 plus 2 is equal to 3. I value becomes 3, so it is going to be 1 plus 2 plus 3. Every time I increments, that value of I is getting added to p. I value becomes 4, then it will be 1 plus 2 plus 3 plus 4. It will go on doing this. For how many times? We don't know that. So let's assume that this goes on for k number of times. This goes on for k number of times. So what is the total time taken by p over here or by this statement over here? Let's add up all of this. So it will be 1 plus 2 plus 3 plus 4 plus up to k. So it will go up to k times. So that is why I have added all of this. So it's going to be 1 plus 2 plus 3 plus 4 plus up to k. So this will go as k into k plus 1 divided by 2. This is mathematical induction. So it is k into k plus 1 divided by 2. So but this particular loop has to stop somewhere. When will it stop? When p is greater than n. When p is greater than n, this condition will fail and the execution of this statement will stop. So let's assume that p is greater than n. This is where the condition fails. Since p is equal to, I have calculated the value of p over here, k into k plus 1 divided by 2 based on the tracing what we have done here. So since p is equal to k into k plus 1 by 2, I'll substitute the value of p over here by k into k plus 1 by 2. So k into k plus 1 divided by 2 is greater than n. What I have done is I have simply substituted the value of p in this assumption that we have made, right? So it is k into k plus 1 divided by 2 is greater than n, which means this will be k square plus k divided by 2. If you solve this equation over here, it will be k square plus k divided by 2. This is a polynomial. What is the highest degree of this polynomial? K square. That is why we have taken only k square. K square is greater than n. So what does this mean? K greater than or greater than root n, which means that this algorithm has an order of root n. So based on what we have learnt just now, there is an exercise or an assignment for all of you. I want you people to calculate the time complexity of these two algorithms. The first one is to calculate the time complexity of matrix multiplication, and the second one, there is a certain set of statements given, two for loops. The first one, I equals to 0, I less than n and I plus plus. Inside that I have a j loop, j is equal to 0, j less than I and j plus plus, and within that you have your statement, that is your basic operation. So for these two algorithms, find out the time complexity. Thank you.